All right, so today we're going to continue in the packet with transformations, and we are going to do lesson 51. Yesterday we worked on our dilations when we had an enlargement, and today we're going to work on our dilations if we have a reduction. So there's a quick do now that I would like you to do here, and pause this video to do so, and then come back to check your answers. All right, so the do now said if we made the triangle half the size, what would be the length of its sides? Well, what does half mean? So we need to think about that. What is half? Well, half is really the same as multiplying by a half. Multiplying by a half is really the same as dividing by 2. So if we were to do this and we were to divide all the sides by 2, half of 4 is 4 divided by 2, which gives us 2 inches. Half of 6, 6 divided by 2 would give me 3 inches. And half of 8, 8 divided by 2 would give me 4 inches. So those would be our new sides if we halved that triangle. So when a shape gets smaller, this is something we call a reduction. So in a figure, if a figure is getting smaller, the scale factor needs to be, well, think about it. What would make something smaller? And most people go to saying it would have to be a negative, but we actually talked about in the last lesson that scale factors always need to be positive. The scale factor is never negative. It's always a positive. So in order to get bigger, it needs to be greater than 1. In order to get smaller, it needs to be less than 1, but since it can't be negative, it needs to also be greater than 0. So it's a value that's between 0 and 1. So 0 is less than k, which is less than 1. So it's between 0 and 1. So it's greater than 0, but less than 1. And what types of numbers are those? So a lot of times they end up being a fraction. Just like we saw here with 1/2. What's another fraction? You could say 1/4. Or maybe 1/3. And so on. So we're going to talk about those reductions today. So if we take a look here, we have a figure that has the vertices J, 4, 8, K, 10, 6, L, 8, 2. And we're going to graph the figure and the image after dilation with a scale factor of 1/2. So the first thing that we're going to do here is let's graph our pre-image. J is at 4, 8. So I'm going to go to the right 4, up 8. And plot J. K is at 10, 6. I'm going to go to the right 10, up 6, plot K. And L is at 8, 2. I'm going to go to the right 8, up 2, and there's L. Then we're going to connect to create our triangle. Then it says our dilation is 1/2. Well, we realized that 1/2 is between 0 and 1. So since my scale factor is 1/2, that means it's going to be getting smaller. And we know that 1/2, when we're talking about scale factor, we mean multiplying. So we're multiplying by 1/2. And we know 1/2 is really the same as dividing by our 2. So scale factor is always talking about multiplying. But we can convert that to a division problem, because multiplying by 1/2 is the same as dividing by what's in the denominator on the bottom of the fraction, which is 2. So we need to do this to all of our values in our pre-image. So I need to take 4 divided by 2 and take 8 and divide it by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. Then we have k. I need to divide my x and my y values by 2 here. 10 divided by 2 gives me 5. 6 divided by 2 gives me 3. Then I have 8, 2. I need to divide these by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So then we have our new points. So J prime is at 2, 4. So I'm going to go to the right 2. Up 4 for J prime. K prime is at 5, 3. So I'm going to go to the right 5. Up 3. And we have K prime. L prime is at 4, 1. So I'm going to go to the right 4. Up 1. And we have L prime. Then we can create our figure. Now we notice it's the same shape, but is it the same size? No, these are similar figures, because it's the same shape, but it's a different size. So now let's look at the bottom one. Now we're going to work backwards. We're given our picture, and we need to figure out what is the dilation that is taking place. Well, let's look. First, we need to figure out which came first and which came second. Well, I see we have A, B, C here, and I know B isn't labeled, so let me do that. And I know that this one came first because it does not have the primes. And then this one came second because it has our primes. So what we want to do is we want to compare our points. So we can pick one pair of corresponding points here. So I'm going to say let's pick B and B prime. And you could pick any pair of corresponding points. Well, B is at 2, 2. B prime is at 1, 1. How do I get from B to B prime? Well, to get from B prime to B, we would multiply by 2, but we're working backwards. So one way to do this is we can create some sort of a relationship here by doing the new over the old. So let's take our new coordinate. The new one is the one with the primes. The old one is the one without the primes. So if we take our new coordinates, so let's compare our x's here. So the new was a 1 over the old, which is a 2. So my scale factor then is 1 over 2, which is just 1/2. So that formula, new over old, is really helpful to figure out our scale factor. All right, so then there are 2 more examples for you to work on. But before you do that, I want to take a look at the problems together. This, once again, has our pre-image that you're going to graph. Then it says the dilation is 1/3. So that means we're multiplying by 1/3. Well, 1/3 is really the same as dividing by our denominator, which is 3. So we could really just take each of these and divide them all by 3 to get our new coordinates. And then this one, we have our pre-image and then our image. We're going to be using that new over old formula to help us figure out what our scale factor is here. And remember, if we're getting smaller, our scale factor is going to be between 0 and 1. All right, and then once you finish this, we are going to work on your practice worksheet over here. So for the practice worksheet, write out the original coordinates to help you with your scale factor. And then here you're going to compare your points. All right, if you have any questions, please let me know and send me an email or comment on the video.